Hello everyone. In my previous video I talked about various degree centrality measures, what they are, how do we calculate them, and how do we go about applying them in real-world applications. Today I want to cover what this looks like on a larger graph, not a huge graph, but just a little bit bigger one so we can see it applied computationally. So this is loosely adapted from a GitHub data repository. So it was included on the cover slide of my presentation. So if you want to go download that, you certainly can. But there are a couple different metrics we can run inside Gephi that gives us data versus having to compute it manually. So first is the degree. And so what we're seeing here is the individual degree of each of these various nodes and how they relate to everyone else. The next thing we can do is we can look at running the network diameter over here. And we can see that in this case we have an undirected network, and we can look at the betweenness and the closest centralities, and then as well as the eccentricity. If we want to normalize these, we certainly can. I kind of covered that in the previous video of what that actually means. So I'm going to go ahead and run this, and then we can look at the individual table for the various metrics. So we can see that we have some different values in here for eccentricity, for closeness, for betweenness, and then also a harmonic closeness, which I didn't cover, but there is information on that available online if you're interested in checking that out. While Gephi provides a lot of use and a lot of functionality, there are definitely instances, or could potentially be instances rather, where we may not have access to this kind of a resource on our system. We could be in a location that's forward deployed, for example, that we don't have any sort of our basic spreadsheets. But at the root of it, we can see that these things are just tables, right? We have, and in fact, both of them are exported to CSVs if we needed them to. So what I want to do is I want to transition to an Excel macro workbook that I created that kind of goes through some basic functionality of Gephi, but in a less resource intensive environment. So the workbook provides 7 different macros for us to kind of play with. The first one we can see is just going to insert a new edge into the graph. If there is a node, or if the edge already exists, the software provides feedback and says that's already there, so we don't mess up our calculations. The next piece is going to be deleting a node, which deletes any edge associated with it. If you misspell an edge, it will not, the software will provide feedback says you misspelled it, because it doesn't exist. The next thing we can see is we're going to calculate our in and out degree centrality. And we'll look at, just like how we did in Gephi over here, the degree. In this case, this is a directed network because I tweaked this code from the, or this graph from the one that's on Gephi. The next thing is we're going to look at some bar plots for total centrality and then the standardized centrality. And the next thing we can do is talk about the shortest paths from one given node to another. So now what I want to do is I want to go ahead and add in a new edge. I'm going to add in John to Theodore. The software provided feedback to let me know I input them correctly. Now I could delete a node, but I will not go ahead and do it in this case, because as the message down here at the bottom says that deleting it deletes any sort of edge attached to it. But what I will do is I will go ahead and add or calculate our degree centrality measures. And as we can see, Robert has an in degree of 16, and here is his normalized score. And as we can see over here, Justin has out degree of 17 with his normalized score. So now what I'm going to do is I'm going to insert bar plots associated with each of these. And we can see that again, Dustin has an out degree of 17, and here's his standardized or normalized score, excuse me. And the same thing over here, Robert's in degree, and then here's his standardized score. So now what I can do is I can also calculate the shortest path between any two nodes. As this runs, we're going to start with Alexa, and then we're going to go to Rufino. The software is going to let me know I spelled them correctly versus not spelling them and the solver would not run. Solver says it found a solution, and I can see that to go from Alexa to Rufino, it has to travel through 5 individual people. And we can go over here and see the selected route column, and we can see what those where the node passed through. And so last thing we can do is just reset the workbook to bring us back to blank slate over here. So again, this provides some functionality of Gephi, and of course you can create code and algorithms for betweenness and closeness with a little bit more work. But again, I wanted to highlight that even without Gephi, there's still some capability to conduct basic graph theory in a constrained environment such as where you're only limited to Excel. Thank you all for watching.